All right, stats, here we are. We got another notes video while I'm out for Tuesday, October 19th. This is your Chapter 10 packet, notes packet here. All right, Chapter 10 is relatively short and easy chapter. Chapter 12, we dive into some more interesting probability. All right, so gonna take a look here at the second page, where it says here for Tuesday the 19th. And then on Wednesday, I will cover your quiz review for you there. And then we shall see where we're going next. So number 2, 1019. So let's say we have a player that is hitting 363 but averaging 4.5 at bats per game. Find the probability that this player gets at least one hit in his next game. Use this probability to find the likelihood that he will hit safely in 10 straight games. So I actually did not do that one, but I will show you how to do it. I don't have my calculator here, so you can help me type that in. Or you can type that in for me. Probability of hitting streak. So one of the all-time sports records that Joe DiMaggio's hit streak of, is it 54, I believe? There was a relatively famous stat project that wanted to see if that should have been broken by now. If there are some non-random elements at play, streakiness, if that's a thing. It was pretty interesting. Radiolab did an episode on that, stochasticity. Anyway, it was very cool. So that could be a master's project you guys can do. So the probability of getting a hit, X is a hit, the probability of getting a hit is 0.6 or 363, sort of batting average is the probability of getting hit. I want X to be a hit. I want the probability that X is greater than 1. X could be 1, 2, 3, 4. Let's hope 4.45. That's interesting. So the probability of getting out is 0.637. We always want to do the complement here. If I want to know the probability that it happens at least once, I can find the probability that it doesn't happen at all. Probability doesn't happen at all. So the probability that X is 0 is 0.637 raised to the 4.45. That's how many at-bats this person averages. Okay, we're going to fail 4.45 times in a row. I know that's not possible, but if you have an average of that many at-bats, that is exactly what the exponent's going to be. So the probability of getting no hits is 134. So the probability of getting at least one hit is 1 minus 0.134. Probability of getting a hit in any game is 0.866. That's the probability of getting at least one hit. So if I win a 10-game hit streak, I want to be successful 10 straight times. All right, so just do 0.866, raise it to the 10th, and round it to 3 decimal places. That's how you do number 2. Again, pause this whenever you need to. I'm going to make this relatively quick. I will try to pause when I can. All right. For Tuesday, the 19th. Number 2 here, it is well known that the probability of getting a batter out dramatically decreases as starting pitcher goes 2 and then 3 times through the lineup. That's a big stat they look at now. So let's say opponents have an on-base percentage. That's their probability of getting on base, which in baseball is good. The first time through a lineup when they face pitcher A. And then an on-base percentage, it's a little bit better the second time it goes through the lineup. And an on-base percentage, that's very good the third time through the lineup. So the game has just started. What is the probability that pitcher A records 3 straight outs? So success for a pitcher is an out. This is the probability of success for a batter. So if we're looking at this through the pitcher's eyes, if X is an out, the probability of getting an out is the complement of that. Do 1 minus 247. That's why I get the 0.753. So the probability of getting an out is a 0.753. I want to get 3 straight outs. So 0.753, raise it to the third. That's 0.427. To start the game, 42.7% chance of getting 3 straight outs. So what's the probability that pitcher A records 3 straight outs the next time the leadoff hitter comes to plate? So the second time through, what's the probability of getting 3 straight outs again? All right. Well, that would be, they have an on-base percentage the second time through of 0.295, as you can see. So 1 minus 0.295 is 0.705. That's the probability of getting it out. Now it's decreased. So I'm going to take 0.705, raise it to the third power. 0.350, a 35% chance of recording 3 straight outs. And lastly, what's the probability that pitcher A records 3, not lastly, but next part, 3 straight outs to start the 7th inning when he's seen the same batters for a 3rd time. Okay? Now, if it's the start of the 7th inning for that, we've got a no-hitter, a perfect game going here. So maybe just the 3rd time through. So the 3rd time through, could be the 8th inning, the 9th inning, who knows. 3rd time through, that means 3 straight outs. The probability of getting it out here is now 1 minus their on-base percentage, 1 minus 0.361. So I get 0.639. And I went 3 straight outs. So 0.369 to the 3rd. Now it's a 26.1% chance of getting 3 straight outs. So something that's not happened a ton. I think it's like 20-something times in the history of the game. Given this data, what's the probability that a pitcher will pitch a perfect game? Now, this person might have okay stats. So what's going to happen? A perfect game is 27 straight outs. So you would get 9 straight outs. That's the first 9 batters. You get them all out. Second time through, the same 9 batters. You get them all out. 3rd time through, the second 9 batters. You get them all out. This is the multiplication property here. So you're going to see the first batters 9 times in a row. So that's part A, 0.753. Not raised to the 3rd, but to the 9th, because you're going to get them just 9 in a row. The first 3 innings, everyone's out. This is the next time through. You see them 9 times again. This is the next 3 innings. This is part B here, but raised to the 9th power. This is part C here. You're going to start in the 7th inning with that leadoff hitter, and you're going to get them all out again. So here the X is a multiplication X here. So 0.693 raised to the 9th. Holy cow, it's a very, very tiny percentage. So in every year, there's 30 teams. They're supposed to play that many games. So that's how many different outcomes. Divide that in 2. That's how many unique games are played. But that's how many outcomes, because you got a pitcher A and a pitcher B. And they both have 2 different outcomes. So technically, this should happen, once every 4 years with these stats. I don't think everyone's stats are that good. Okay, and that's if we just let them keep going, which they don't. They yank. Now, if someone's got a perfect game, they'll probably let them keep going. All right. So there you go. That's it for number 4. Relatively interesting, like baseball. This is a good one. I do ask questions about this on quizzes and stuff. So in order to become a professional licensed employee in a certain analytic field, you must pass 3 professional exams. A lot of fields have this. You got to pass 3 different exams or more or whatnot to either get paid more or to enter. I had to take 3 different tests in order to become licensed to teach, and there's just so many fields. Actuarial sciences do this, insurance, obviously, medical fields, the LSAT, the bar. You guys get it, okay? So one of you just sent me your homework set there. Very nice. You guys are already reading. Excellent, excellent. Again, you are in a college class, so you're most definitely expected to read emails and watch videos, okay? This is obviously not a fan of being out, but one of you others sent one as well. You guys are on it. Excellent. Those pop up in the way of my video, but that's all right. So what's the probability that you pass all 3? Well, first off, if you're looking at these numbers, how come you have a better chance? I'm assuming these tests are getting harder, right? For me, you had the basic skills test, then you had the content exam. That was the hardest one, math. And then you had just some other tests. It wasn't too bad. But in some, how come, let's say they actually easier, middle, and then harder. Well, you might have a lot of people that think that they can do this certain field, and they don't really study very hard, or they're just not cut out for it. So they just bomb the first test. Maybe they bomb it twice. They're like, all right, I'm done. I'm moving on to something else. The second time through, you've got everyone A that have passed the first exam and maybe have been serious the entire time. And the third one might just be hard. All right, so what's the probability that you pass all 3 of them in a row? 0.71 times 0.74 times 0.63. You have a 1/3 chance. All right. What's the probability that you pass the first 2 tests and fail on your first attempt of the 3rd test and add this in and then pass the 3rd test? This has a happy ending. You pass. pass it. You've made it. All right, so you pass the first two, you get to the third one, you fail it the first time, and then you pass it. So what's the probability of pass, pass, fail, pass? Or the probability, the first test you pass, second test you pass, then I underline this because that's what happens on the third test. On the third test, you fail it, then pass it. So the probability you pass the first one times the probability, this is all about multiplication. This is all one event here. You pass it, fail the third test, and passed the third test. Now, how did I get 0.37? If the probability of you passing the first test is 0.63, probability of you failing the third test is 0.73, the complement. 1 out of 8 people follow that exact path. That is interesting. So then what is the probability? Because you have to pay for these tests. Maybe your parents said, I'll pay for 4 of these tests. You get 4. Anything after that's on your own. All right, so what's the probability that you pass all 3 exams in 3 or 4 attempts? Well, from part A, we know the probability that you just go on through is 0.331. All right, so you've got 3 different instances of passing these 3 tests in 4 attempts. You could, maybe you don't prepare well for the first one, then you really buckle down because this is what you want to do. You fail the first test the first time, then you pass it the first test, then you pass the second one, then you pass the third one. So if you pass it in 4 attempts, you pass 3 of them, all of them, and you fail 1 of them. So you fail the first one, then pass the next 3. So if you have a probability of passing the first test of 0.71, the probability of failing the first test is 0.29. This is all the first test. That's the second test. That's the third test. And that is 0.96. Like 1 out of 10 people do that. Then I could pass the first test, and then my first attempt of the second test I fail. Then I pass the second test, then I pass the third test. That's the first test. That is the probability of failing the second test, probability of passing the second test, then I pass the third test. 0.86. That's close to 1 out of 11 people do that. And then lastly, this is from part B, pass, pass, fail, pass. I already know that. So then you add them all up. Add them all up. 0.635. A little better than 5 out of 8 chance of passing in 3 or 4 attempts. All right, so then we are going to go, because we're going to finish this packet here on Tuesday. We are going to go to your page at the top. It says Chapter 10 Exercises, page 285. We are going to go to 1041, and I've actually not done any of these. So let's see. Why is this a legitimate probability, a discrete probability model? If you add up all these, that's 0.18. If you add up all these, that's 2.6. If you add up these in this column, that is 27. If you add up these, that's 29. 56 plus 44 is 1. All right. So all the probabilities add to 1. What is the probability that a person chosen is a 19-year-old who lives in his or her own place? So think of this as an Excel, sheet or Google sheet. We want to look for this exact cell of being 19 and in your own place. That is an exact cell, 0.04. What's the probability that the person is 19 years old? You're going to add up those numbers. If you add up those numbers, you get 0.18. What's the probability that the person chosen lives in his or her own place? Own place would be 04 plus 09 plus 13 plus 16. So the first 2, if you add them together, that's 13. And the second 2, if you add them together, that's 29. So in total, that's 42. All right, so this is an interesting one. The person is either 19 or lives in their own place. So here's the thing. They're 19 and they live in their own place. So if you do it like that, folks, you have overcounted this 04 twice. You're 19 or you live in your own place. I can add them in either way, but I've counted an 04 double. There's an intersection of being 19 and in your own place. And we'll talk about this in Chapter 12, the union and intersection, probability A union B or probability A intersection B. Why is it not the sum? I just said because you've overcounted. You simply can't take 0.18 plus, Yeah, it's right there. You can't simply do 0.18 times 0.42. I mean, you could to get started, but then you would have to subtract that 0.4 that you've overcounted, the intersection of being 19 and having your own place. So the answer is 0.56. And you can either do that, which is 18, plus that, 37, plus that, 50. I'm sorry, 27. Do this, plus this, that's 27, plus this, that's 40, plus this, that's 56. That's another way to get that. All right, so we can't see this, but 21 says, what's the probability that a person is 21 years or older? So that would be those two right there, 0.27 plus 0.26. 27 plus, I'm sorry, plus 0.29. 0.56. What's the probability that a person chosen does not live with his or her parents? So why don't we just do 1 minus the probability you live with your parents. The probability you live with your parents is 1, 1 plus 1, 3. That's a 19 and 20-year-old living with their parents. And then 1, 1 plus 1, 1. That's a 21-year-old and a 22-year-old living with their parents. 1 minus 4, 6 is 0.54. There you go. All right, that's a pretty interesting question. And then on the last one, we're just going to do 44 and 47, and that will be a good notes video for Tuesday. And I'll tell you, again, I'll remind you about the homework sets here in a second. All right, spell checking software catches non-word errors that result in a string of letters that's not a word, such as the is typed as TEH. When undergraduates are asked to type a 250-word essay without spell checking. Oh no, that's one of my nightmares. The number X of non-word errors has the following distribution. So 10% of them don't make any. Kudos to them. 20% of them make 1, 3, 4, and then let's just 3, or let's just say 4 plus. It's discrete. Why is it discrete? It's discrete because the value, so do write this down, the value of X can only be counting numbers, whole numbers, no decimals. The value of X, your variable, can't be a decimal. Like your height is continuous because it can be decimal. Your weight's continuous because it can be decimal. Temperature is technically continuous, it can be decimal. But number of errors, number of points, number of goals, number of assists, discrete. Write the event at least one non-word error in terms of X. At least one. At least you have equality. X is greater than or equal to 1. And we're just going to do 1 minus probability that X is 0. 1 minus 0.01. I'm sorry, 0.1. That's 0.9. Describe the event X is less than or equal to 2 in words. So this is 2 or fewer. 2 or fewer errors. 2 or fewer. What is the probability? So that probability 2 or fewer would be that plus that plus that. That's 0.6. What is the probability that X is less than 2? Now the probability that X is less than 2 would just be that. If you have less than 2 errors, you have 0 or 1 errors. So that's 0.30 for that second part. Now we'll do that in a quiz review. That sometimes is a challenging one for students. All right, let's talk about birth order. The Binford errors one is cool. We can talk about that one in class. Birth order. A couple planets have 3 children. There are 8 possible arrangements of boys and girls. For example, GGB means girl, girl, boy. All 8 are equally likely. So this is asking, what's the sample space? What's the sample space of this? So let's list the ladies first. You can have 3 straight. That's a G. You can have 3 straight girls. Make my G stronger. Then you can have a girl, a boy, a girl, a boy, a girl, and a boy followed by 2 girls. That's all the chances of having. This is the same thing with tossing a coin 3 times. Hint, hint. Wink, wink. Which, good. I'm going to give you some guidance. I'll have to see if I gave you your chapter 10 homework set. I got to look that up. Because I'll give you some guidance on that too, because that's something we can now handle on our own. Okay, so then I could have a boy, and a girl. I could have a boy, a girl, and a boy. And lastly, here, I could have a girl, boy, boy. That is the 3 outcomes of having 2 boys. And lastly, I could have 3 straight boys. That's 8 of them. 4, 4. And how did I know it was going to be 8? Well, there's 2 outcomes, boys or girls. And you're going to have 3 kids, so it's 2 times 2 times 2, or 2 to the 3rd, and that's 8. Same thing with flipping a coin. 2 times, that's 8 possibilities. 4 times, that's 16 possibilities. Let x be the number of girls. What's the probability that x is 2? If x equals girls, the probability that x is exactly 2 is right there, 3 out of 8. Find the distribution of x. Oh, I mean, you could... Okay, all right. Here's what C means. So what's the probability that you have 0 girls? It's 1 out of 8. What's the probability that you have 1 girl? That's 3 out of 8. What's the probability you have 2 girls? That's 3 out of 8. This is part C. And what's the probability that you have 3 girls? That's 1 out of 8. If you add them all up, you get 8 out of 8. That's your distribution of x. If x is girls, that's the distribution. Probability you have 0 girls, 1 girl, 2 girls, and 3 girls. All right, man, you have a heck of a video. I always start these on time here because you might have to pause them, especially when I get into helping you for your quiz review or any homework help. Hence, wink, wink. Again, this is the review homework set. It is entirely a review going back to the first days, and this is now going to be due via a scan, now due. And so instead of Wednesday, because for some of you might not have done the whole scan thing before, I might make a video on how to do that because some kids in calculus might need that help. But I've got some other note videos that are taking precedent here. So this is now due Thursday by midnight to my email. 2 of you have already done that already. Excellent job. All right, folks, this is Yak Math Videos signing out.